So a ball is thrown off a cliff with a velocity of 15I plus 7j meters per second. I is the horizontal velocity, so how fast it's travelling across and what direction. J is its vertical velocity, so how far or how fast it's travelling up and down. The ball accelerates due to gravity and experiences no air resistance. So accelerates due to gravity, that's a acceleration in the J direction, the vertical direction, because gravity pulls straight down. Experiences no air resistance. That means that it doesn't slow down in the horizontal direction at all because there's no forces or anything acting on it in the horizontal direction. Given that it is in the air for t equals 5 seconds, how tall is the cliff, what horizontal distance does the ball travel, and what is its final velocity? Okay, so finding the horizontal direction is relatively easy if we want to do that on its own. It's slightly harder to do the vertical direction, so let's do it together. So first thing we're going to do is draw a bit of a diagram. So there's our cliff. So obviously the cliff's up here. We don't know how tall it is, but we do know it's projected at 15I plus 7j. Okay. What else do we know? Well, so that's our u. We don't know v. We know t equals 5. We know a. Well, gravity, 10 meters per second squared. Normally we use 9.8 because we're told 10. We're going to use 10. Gravity only acts in the vertical direction, and if we're taking upwards as positive, the reason I'm taking upwards as positive is because you're going to imagine that it's not projected like straight down, because it says upward vertical velocity as well. So this has to be negative because gravity pulls you straight down. So this is going to be minus 10j meters per second squared. Okay, so there's our u. We want to find s and we want to find v. Okay, so first I'm going to use s equals ut plus a half at squared. That looks a bit like a plus a half at squared. Okay, so subbing the variables that we know, u is going to be 15I plus 7j times t, which we know is 5. Plus a half at squared, so plus half times acceleration, which is minus 10j, times t squared, which we know is 5, so 5 squared. Okay, so working this out, you can just times each component as if you were doing algebra. So 15I times 5 is 75I. 7j times 5 is 35j. And then this, you're going to do half times minus 10, that's minus 5, times 25, because 5 squared. So we're going to have minus 125j. So what are we going to get here? Well, add the j components together. We get 75I, because there's no other I component in this. 35 take away 125, so that's going to be 90, so minus 90j. Okay. So this is our displacement. So how far does it travel horizontally? Well, remember, I is its horizontal velocity, so it must go 75 meters horizontal. And then notice how it's minus 90. That's because it's gone up and then down. So the cliff is 90 meters tall. Okay, so we've done that. We've done the horizontal distance. We just need the final velocity. So what I'm going to use is v equals u plus at. Sub in what we know. So v equals 15I plus 7j. And then plus minus 10j times 5. So you're going to have 7 minus 50 because minus 10 times 5. So we'll get 15I minus 43j. This is its final velocity. So it's going 15 meters per second in the horizontal direction, 43 meters per second in the vertical direction. Downwards, straight down because it's negative.